we are putting on a conference called Evolution Exposed.
We pulled in experts on the subject of evolution
For a total of 11 speakers,
and gave them just 15 minutes to give us their best.
and on top of all that, a 1-hour Q&A panel session.
You're going to love Evolution Exposed.
Anyone can refute evolution.
Zoo to the zoo to me and you.
Call that a fairy tale.
Not allowed to ask questions.
It made evolution look ridiculous.
Shows the foolishness of atheism.
I knew I was going to get corrected.
No, I wasn't even listening to your answer, Eric.
This guy might be coming for you.
Welcome to Paulogia and another installment of Evolution Exposed, our claim-by-claim investigation of the Creation All-Star Mega Seminar. If you'd like to catch the series from the beginning, tap on the playlist above my head. To accommodate guest schedules, we're going to come back to Dan Biddle's Dinosaur Burial segment and move on today to his thoughts on biomaterials in bones.
Next, we find one of the most convincing things that actually was instrumental in flipping me into becoming a young Earth creationist is these strange biomaterials that are found in dinosaur bones. In fact, it used to be 13, now when it was 14, now there's 15 different types of fresh bioorganic materials that are found in dinosaur bones.
I think it's funny how excited creationists have gotten over the discovery of dinosaur soft tissue, and while it is indeed interesting in some respects, it's definitely not an argument for a young Earth. When first discovered, the existence of soft tissue in the fossils of non-avian dinosaurs came as quite a surprise to researchers. Previously, the oldest soft tissue outside of amber fossils was only known from organisms tens of thousands to hundreds of thousands of years old. Finding collagen preserved in a tyrannosaur femur launched paleontologist Mary Schweitzer to fame in 2005, and since then, a number of other fossils have come to light with their own preserved soft tissues, such as Brachylophosaurus, Lufengosaurus, Tarbosaurus, and some Mesozoic marine turtles, among others. Did this amazing fact overwhelm paleontologists and force them to become young Earth creationists? Well, no. Indeed, to borrow the term that Biddle uses earlier in this video, there is an evidence mosaic that indicates a global flood not only didn't happen, but couldn't happen. Furthermore, even if it did happen, then dinosaur soft tissue doesn't indicate it. Nor does dinosaur soft tissue indicate that the Earth is 6,000 to 10,000 years old. Biddle says here that there is, quote, fresh bioorganic material found in dinosaur bones. First, I'm going to take extreme issue with this claim. Has any dinosaur fossil been found which appears as though it died within the past few weeks? No, of course not. Then it's not fresh. Biddle calling soft tissue from any fossil fresh is highly misleading. Is the flesh from permafrost mammoths, wolves, or woolly rhinos fresh? Again, no, that just isn't what fresh means.
How do you preserve that over 65 million years? This doesn't look like a rock. It's stretchable. All you have to do is dissolve away the calcified matrix of the bone and you're left with this stretchy tissue that this one was found on the inside of a Triceratops horn.
So this example is quite funny. For starters, there's a very good circumstantial case to be made that the alleged Triceratops horn discovered by creationist Mark Armitage is in fact a Pleistocene bison horn. Armitage performed no stratigraphic analysis of the site where he dug, and two other creationists who worked with Armitage on the horn, Kevin Anderson and Otis Klein, claimed the horn came from a site that is known to contain both Cretaceous and Pleistocene strata. Armitage's paper doesn't provide an age of the strata he worked in, a fact which would have been caught by any paleontological journal, hence why he published in a microscopy journal. Armitage knew researchers trained in microscopy would check his microscopy work, not his paleontology work. Evidently, no independent researchers have had access to the horn since Armitage published, so no one can verify the veracity of his claims. His claims are absolutely brimming with red flags. Additionally, Biddle refutes his own claim about freshness. He says that the material is pliable once the calcium exterior is dissolved away. If you were dealing with fresh proteins, why would you need to decalcify them?
And even the leading director of the Royal Tyrrell Museum, the largest dinosaur museum in the world.
Hey, Royal Tyrrell. That's just a few hours from my house. I've been there many times. It's amazing. If you're ever in Alberta, you need to go.
says that usually most of the original bone is still present in a dinosaur fossil.
I want to deal with the ending quote first, then we'll get to the point about soft tissue being preserved, because this is the bulk of the argument.
Well, given that I have a connection to the museum, I reached out directly to Dr. Curry to get clarification on this quote fragment from a book that he wrote primarily for children. Why is it that evolution deniers so frequently pull from sources like this, rather than peer-reviewed papers? Anyhow, I asked Dr. Curry what he meant by most of the original bone is still present. He kindly replied, every site that produces dinosaur bone is different, and it mostly depends on whether the groundwater, which carries the minerals in solution, that crystallize inside the miniature cavities in the bone to permineralize it, that soaks into the bone carries minerals, usually quartz, calcite, iron, but also not so common minerals in most places, like uranium. If a modern bone falls into a mineral spring, for example, it can absorb materials very quickly, and the bone can fossilize in a few years. If there's no groundwater with mineral passing through the sediments, as in arid regions, then the bone can sit unchanged for thousands of years. In both cases, most of the original bone is still there. After all, it is hard, and the minerals just fill in the spaces. Groundwater in different areas carry different minerals, which is why the resulting fossils have different colors and densities.
In many cases, bone calcium carbonate is replaced with soil minerals over time, a process called permineralization. However, sometimes the original calcium carbonate bone material can be left in dinosaur bones. Does this undermine the old age of the Earth? No. Think about what calcium carbonate is. It's a rock. Limestone is also a calcium carbonate rock. Your skeleton is already made of a type of rock. So is it especially surprising that a rock would be preserved? No, not really. Are osteocytes and bone marrow usually preserved? Also no. Soft tissue is normally degraded, but it can be preserved in certain instances, hence why we're here.
As Dr. Curry affirmed, just think about it. Soft tissue disappears because it rots, and it rots because of microorganisms. If you surround and seal a bone in a mineral casing, or it's in groundwater that geochemically does not allow microorganisms to survive, the soft tissues in the bone have no reason to rot. The fossilization process is very complicated, and there's no reason to think it takes millions of years to accomplish permineralization. And there's no reason to think that under the right circumstances, something even as complex as DNA might not survive for millions of years. After all, if it can survive for hundreds or thousands of years, or even days for that matter, the right circumstances almost certainly allow it to happen for millions of years. Jurassic Park? I think it's highly unlikely, but I no longer think it's impossible.
Now let's understand what dinosaur soft tissue has been preserved, and then let's understand by what method the soft tissue can be preserved. Biddle and other creationists act as though dinosaur fossils are just bursting with soft tissue, practically bleeding as paleontologists excavate them. This is far from the reality of the situation. As it happens, the soft tissue, indeed osteocytes, blood vessels, and red blood cells, are microscopic and only stretchable once the calcium has been dissolved away. So we have micrometer-long fragments of cells and vessels trapped inside rock tombs and sheltered from bacteria and the elements. At that point, you'd be justified in asking, well, why wouldn't they be preserved? Furthermore, the burial environment seems to play a role in the preservation of soft tissues. River and sandstone deposits seem to preserve soft tissue better than mudstone and marine deposits. This might possibly relate to water being more likely to act in the degradation of soft tissues, i.e. hydrolysis reactions. Therefore, more arid environments are more likely to preserve soft tissues. But there's a biochemical side to this story as well. One of the proteins routinely found associated with these soft tissue remains is collagen, which is an extremely hardy biomaterial. The reason for this hardiness is that collagen is a triple helix that forms crosslinks between the strands. Crosslinks stabilize molecules by providing structural reinforcement. The more crosslinks a molecule has, the more resistant it is to fragmentation. In some cases, crosslinks can even reform polymer backbones after breaking. As biochemist Fazal Rana says in his book, Dinosaur Blood and the Age of the Earth, quote, "The intertwining of the collagen protein chains and fibrils, along with the extensive cross-linking between the collagen chains, makes collagen an incredibly durable material. This property makes collagen well suited to form the connective tissues found in animals. For that reason, it isn't surprising that some collagen fragments would survive in fossilized dinosaur bones. Even if the individual protein strands break down, the fiber would still remain largely intact because of all the association points. Once the protein strand breaks down, the fragments are held in close proximity by the contact points. This forced closeness allows for broken strands to occasionally rejoin and reform the original protein. If the broken strands were not held juxtaposed to each other, the fragments would diffuse away from each other, thus preventing the reversal of the degradation process." Close quote. Similarly, keratin and chitin, other examples of soft tissue preserved in fossils, are full of crosslinks that make them highly durable. Another biochemical feature that makes some molecules highly durable is called electron delocalization. Take graphite. Graphite is composed of repeating units of ringed 6-carbon molecules that form what are known as aromatic bonds. In essence, this means the molecule's electrons can move freely from atom to atom. Normally, electrons can only move between the two atoms that form the chemical bond, but in aromatic bonds, such as notably benzene, the electrons can move much more freely. For chemistry reasons we're not going to get into, electron delocalization is highly correlated with increased molecular stability. That doesn't mean the molecule is less reactive per se, but more electron delocalization means more stability. Graphite is highly stable because it is composed of numerous repeating 6-carbon rings that have delocalized electrons. Eumelanin is another soft tissue that has been found in fossils, such as the ink sac of ancient cephalopods. Eumelanin forms bonds between its molecules that allow for electron delocalization, and, in addition, eumelanin has extensive crosslinks between its molecules. Another molecule, heme, serves as the oxygen binding site in red blood cells. Heme is composed of 2 parts, a porphyrin ring and an iron atom at its core. The porphyrin ring itself is composed of 4 pyrrole molecule rings sharing aromatic bonds. The iron atom in heme has also probably played a role in preservation. Iron catalyzes the production of reactive oxygen species, such as hydroxyl radicals, which can induce cross-linking in organic molecules. Schweitzer and colleagues found iron in association with soft tissue and tested whether iron plays a role in soft tissue preservation. She performed an experiment where one set of ostrich blood vessels was soaked in a solution containing hemoglobin and another set was soaked in pure water. The water-soaked vessels degraded, but the hemoglobin-soaked vessels didn't. Third, quinones, which have been found in 340 million-year-old crinoids, have oxygen atoms bound by double bonds to a 6-carbon ring, which allows for electron delocalization. Over and over, we see that the organic molecules with the hardiest molecular structures are indeed the ones that survive the longest. Big surprise. To conclude, both environmental and biochemical conditions contribute to the longevity of certain biomolecules. With all of that in mind, let's get back to the video.
Collagen is what's infused with bone mineral to make our bones both solid and stretchable at the same time. And collagen provides a soft tissue matrix that's inside of our bones. And scientists have come up with 5 different studies showing that collagen should not last more than 1 million years. So if collagen has a maximum life of only 1 million years, why do we find it in dinosaur bones that are supposedly 65 million years old?
Have 5 studies really shown that collagen can't last more than 1 million years? Well, Biddle doesn't provide his sources, another big shock. But I eventually managed to find the papers. Creationists Brian Thomas and Stephen Taylor published a survey of biomolecules in fossils in 2019 titled Proteomes of the Past, The Pursuit of Proteins in Paleontology, that appears in the journal Expert Review of Proteomics. It is this article that Biddle is referencing when he says 5 studies have shown collagen can't last more than 1 million years. Rana expresses skepticism on the applicability of such studies in his book. In 2011, Mike Buckley and Matthew James Collin observed collagen loss in cow and human bones at 90 degrees Celsius, or 194 degrees Fahrenheit, for a month. They then used the Arrhenius equation to determine how long it would take for collagen to degrade to only 1% of the original material at 10 degrees Celsius, or 50 degrees Fahrenheit, and the number they came to was 700,000 years. There is a bit of a problem here though. The Arrhenius equation only works if the temperature and chemical composition of a system remain essentially stable the whole time. Good luck with that. Additionally, the study wasn't concerned with how long it would take for chemically and physically altered collagen to persist in fossils, but how long isolated collagen that could still be identified as a source of genetic information would last. But the researchers also make an important point which apparently went unnoticed by creationists. Quote, collagen could plausibly be detected at lower concentrations in much older material, but likely in a diagenetically altered state and at levels whereby separation from endogenous and exogenous contaminations is much more time-consuming, costly, and perhaps applicable only to atypically large taxa that can offer sufficient fossil material for destructive analysis, close quote. Therefore, chemical and physical alteration could allow the biomolecules to last for substantially longer. One final note on that Thomas and Taylor paper, they say, quote, no serious rebuttals of iron preservation have yet emerged, close quote, which stands in stark contrast to other creationists constantly asserting that iron has been proven to not allow soft tissue to last long enough. Maybe creationists should read other creationists.
Just a couple more things here and I'll close down because my time is out. More recently, they found some cartilage shells in a baby duck-billed dinosaur, and carbon-14 has also been found in dinosaur bones. Carbon-14 has a maximum shelf life of between 60 and 100,000 years.
Well, no, there is no maximum shelf life. One way of thinking about a half-life is how long you have to wait for a particular atom of a radioactive isotope to have a 50% chance of having decayed. You can think of it kind of like a coin toss, but one that takes a long time. Let's say you toss a lot of coins, and every time a coin comes up tails, it's removed. Just for ease, let's say that we do this with 1,024 coins. After the first flip, we should expect to have about half of them left, or 512. Now, if we think of this in terms of half-lives of carbon-14, that means we waited 5,730 years, and now 512 or so of our carbons have decayed to nitrogen-14. Now, if we flip the coins again and again, we will keep cutting our number roughly in half. After doing this a total of 10 times, we should on average have only one coin. But let's say we flip it and it comes up heads, so we keep it. And then it happens again. In principle, there is no maximum number of flips before we are guaranteed to get rid of our last coin. Similarly, each flip is like waiting a half-life and checking the remaining carbon-14. There is no theoretical maximum time span for carbon-14 to last.
Yet study after study consistently shows carbon-14 found in dinosaur bones.
Carbon-14 can indeed be found in Mesozoic fossils, not just dinosaur bones. And while Dan Biddle here didn't mention it, in diamonds too. I bring it up because he does on his own YouTube channel, and he had a slide for it, but I think he rushed in order to finish his section on time. How does this happen, since Biddle is broadly correct that the C14 that was present in a dinosaur as part of its body when it died should either all be gone or be so uncommon as to be essentially undetectable? So we have essentially two options. Either the radiocarbon is really from the original organism and everything we know about nuclear physics, chemistry, geology, and biology is wrong, or there are ways for C14 to enter fossils in trace amounts even after millions of years. As it turns out, there are a number of ways to introduce small but detectable amounts of radiocarbon into a fossil, even after millions of years. Let's talk about the most fun one first, radioactive fossils. Most people don't know this, but sometimes fossils are quite radioactive, to the point that you need to limit your exposure time to them, and they should be stored in lead-lined boxes. Now, most fossils are no more radioactive than, say, a chunk of rock, which isn't not radioactive at all, but it's perfectly safe. Remember, Grand Central Station in Manhattan is mostly granite, and it's more radioactive than the average fossil. But still, there is radioactivity in fossils, and some of that takes the form of gamma ray emissions. If there is nitrogen and neutrons flying about, you will generate carbon-14, even under the ground. Since nitrogen is a common element in fossils and even occurs as an impurity in diamonds, both should be expected to contain measurable radiogenic carbon-14, formed after the fossil's organic carbon-14 should have decayed to undetectable amounts. But there are simpler ways to get carbon-14 into fossils, and that is contamination. The world is full of life, including bacteria, plants, insects, etc., all of which can get into the cracks in the rocks and leave behind their fresh new carbon. In fact, contamination is a well-known problem with fossils, and it is one of the reasons that some remain unconvinced by claims of dinosaur tissue finds from Mesozoic fossils.
And interestingly, we have dinosaurs that have also been mummified. Here's a picture of Leonardo, one of the top 7 mummified dinosaur fossils in the world. You can still see the stomach and gullet contents of this creature, what it was eating. Ferns and magnolias have still been recovered from this creature's gullet. So you certainly can't preserve that for 65 million years.
There's no particular reason to think that Leonardo couldn't have been preserved for millions of years. The preservation of Leonardo is exceptionally good, but it isn't of an unheard of type. Leonardo is not a mummy in, say, the sense of an Egyptian mummy, where most of the original tissue has been preserved, and much of the chemistry is actually the original biological chemistry. The soft tissue that we can see on Leonardo are not original organic material, they are impressions left in the fine-grained sandstone in which it was buried. We're seeing the same kind of thing that we see with some regularity, we're just seeing a lot of it with Leonardo. And really, the thing about the stomach contents that is exceptional is not that they were preserved, but that they are identifiable as stomach contents, rather than just bits of plant debris that were also washed up with the carcass. Plants actually preserve quite well in the fossil record, being composed of cells with walls made of cellulose, which is hard to digest, and therefore long-lasting. Plant fossils are commonly found with animal fossils, including in the region where the gut would be. The reason that these are not typically reported as gut contents is that it is more likely that they were simply washed there. In the case of Leonardo, this is significantly less likely because they are more localized and the skin impressions of the animal indicate that the torso was probably more or less intact upon burial by sediments, meaning that for the plant fossils to be there, they probably had to have been inside the body of the animal. I'm honestly not sure what Dan Biddle's argument is here. It's just, gee whiz, that fossil is cool, therefore it has to be young? Leonardo is an amazing specimen, but nothing about it even hints at a young age.
Okay, so that's basically the wrap-up of my presentation. I know it's a lot of information we covered quickly, but if you couple this information with the coal and oil deposits, you have all kinds of evidence lines that solidly point to the worldwide flood that's described in Genesis chapter 6 through 9.
I mean, there is literally zero evidence that points towards a global flood that could match the description given in Genesis 6 to 9. In fact, even young Earth creationists have published papers directly contradicting the model that Dan Biddle is pointing to here, that the flood killed all the Mesozoic dinosaurs in a single event. I have a whole video series called An Asteroid Killed Every Dinosaur Ever, all about Dan Biddle's craziness that he puts forth not just in this seminar, but also on his YouTube channel with a dozen or so sources, including some from creationists that just flatly contradict the idea that a global flood is even a possible explanation for any Mesozoic fossils, never mind all of them.
While you're checking out that series from Dapper Dino, be sure to subscribe and let him know that Paulogia sent you. And if for some reason you're not already subscribed to longtime friend of the channel Jackson Wheat, please also fix that today for his amazing book, his amazing work, and his groundbreaking video on whale penises. Up next on Evolution Exposed, E.Z. Swain tells us his creationist horror stories.
You know, a lot of Christians are often terrified when it comes to sharing the gospel with unbelievers because they never know when they might just come across an unbeliever who's an evolutionist.
Oh, don't do that!
See you over there.